All right. Well, thank you first of all to Raja and Mike for this great opportunity. I'm gonna first of all, my name is Jose Villamizar, and currently I am entering my thesis year here at New School. I'm going to focus my presentation on how computational logic facilitates fabrication and how it informs form at a very realistic level. I'm going to present one of my favorite computational projects that I've been a part of in order to support this statement. The reason why this project is my favorite is because I was able to be part of a great architectural and artistic collaboration, but also because of projects like this, I have found recently that I was accepted into an architectural master's program for computational design in Barcelona. So that was my introduction. Great. So the event that I was part of was called HelloWOOD. HelloWOOD works closely with a famous European festival called the Sziget Music Festival, and this is in Hungary. The week-long program is located in the colorful fields of Csánpuszta, Hungary, and the setting for this gathering was in a beautiful farm that was purchased years ago by then a group of artists, designers, photographers, and architects. The notion of this idea of purchasing this farm was to bring a culture of diversity and advanced thought to the idea of quote-unquote art. What they wanted to do is bring a culture that bring 100 designers of 100 of the best young designers around the world and kind of invite them to further develop their aesthetic level, but also different focuses in architecture. There was a variety of different groups going from computational design, graphic representation, obviously architecture, and what was the other one? And theory. The opportunity was created for designers also to interact with each other and work together. But the conclusion of this collaboration is to produce a dramatic installation for the Sziget Music Festival. I was part of this architectural experiment, as you can see in the picture, exactly a year ago. I wanted to use this picture because in the background is the installation piece that I created through computational logic. The theme for the 2014 HelloWOOD event was balance, and as a designer, I believe that balance is a point of departure and analysis when it comes to architecture. And as an individual, I believe balance becomes an objective to facilitate change and discipline. For this event, balance was a very interesting noun that many designers were able to interpret through the visualization of space. Each design objective is to map an image with both tangible and intangible properties and forces. Through symbolism and realism, the abstraction of the dimensionality tackled through the various aspects of the concept of balance. HelloWOOD, and I'm going to read this from their website, is HelloWOOD aims to create pieces that can capture the delicate moments of equilibrium by reacting on uncertainty, skepticism, or disproportion. Notions that can be easily translated to language of architecture. This is the idea of balance I'm referring to, the unpredictability of natural objects, meeting a design influence and discipline. My initial focus for this collaboration, and this is the picture of how the installation looked inside. I still don't want to show everything, so you guys can understand kind of the process that I took from design perspective, but also from computational design logic. My focus for this collaboration was a complex and dependent relationship between high-tech, low-tech, computational design and fabrication techniques. In my opinion, high-tech is defined by the computational logic and the software hunt, quote-unquote, that many designers have dwelled on. Low-tech is the contemporary fabrication and building techniques that have been continuously relied on and have remained at a static phase from my perspective point of view. I believe that these two concepts are heavily influenced by each other, and are significant in need to work constantly for a common goal. In order to simplify our design through space, we constructed a composite design based on these two ideas. The architectural views, when it comes to working with wood, I believe balances the given distribution of two very important concepts. Concept number one is the human exploitation of wood's natural capability. This notion focuses on the design parameters that the craftsman wants to relate through his work by showing a complete control from the rigidity of the wood. This control is visible through the process that designers put the wood through. It can entail everything from cuts to bending techniques. Concept number two is to allow the wood to generate its own personification or image. As designers, we have fallen in love with the use of wood, or the vast uses of wood, because of its aesthetic properties and practicality. This belief focuses on the appreciation that wood has already established in its own lifetime. A degree of uncertainty is present because of the materiality precedents that each piece of wood expresses. Color, I'm going to call it fingerprint, which is kind of like the design aesthetic. Curvature and smell at some degree are all properties that the wood expresses and already processes, or that already has before brought into a design competition or a design project. These two ideas allow all wood designs to successfully relate to the human and natural context. The design of this happening was a collection of architectonical explorations between a few designers and myself. The language I wanted to develop fell in the fundamental investigation on how materiality allow construction and design to really work together. We chose to deform wood by bending it because it was a very attractive and compositional design approach. Bending wood was the closest artistic definition and expression to the variety of concepts within the architectural world. Computational design was a necessity in this specific project because of the high-tech and low-tech environment, because it allowed for the process in a short period of time. It also allowed assistance within our limited tools and manage our budget, and obviously accelerated fabrication. Before I go on, this project was a week long, so nothing was brought to the table other than our ingenuity and everybody's Mac. So from there, we really had to fall into design really quickly, start fabrication really early into the stages, and move forward. And the collaboration was really interesting because it was between a group of us which were focused on computational design. I'm gonna start right here. For the video, I'm gonna wait for 2 seconds. So CODA and MBT led this investigation where a series of questions regarding fabrication, material connectivity, and form. In the forms of the fields of Család, Hungary, we had limited resources and tools, which we had to take into consideration. There was no 3D printers, no cooked robots, or laser printers were available. Only, like I said, our ingenuity and I guess our limitless amount of creativity. Modern tools were available, but wisely used because we only had 8 hours a day to work with them. It was kind of like a few of the limited rules that they imposed on us. It was really interesting because we had to wake up at 8 a.m., had some breakfast, and then throughout the day have some type of, we had to work pretty much. But the tools were limited in the aspect that there was only a set amount of drills. There was only a specific amount of cutters, et cetera. So modern tools were available, but had to be wisely used. The progress of our idea was solidified actually through the design of the computational framework or formwork in order to further investigate the complexity of how wood deforms and bends in an adequate manner in order to introduce into our design. Wood bending is a fascinating quality which became a topic of conversation due to the modern techniques and fabrication characteristics that were available to us. Rhinoceros and Grasshopper 3D were the fundamental tools for this initial deformation. Through Grasshopper, a digital foundation was created, which involved the plugin Kangaroo. This plugin was developed by Daniel Piker, and it was a critical component for composition because we were able to map and input a variety of parameters involved within our design. The computational definition created for this installation was based on how does wood react to a force and how it would be held together for transportation. This video, I wanted to put a video where I actually failed. This is one of the first definitions that I created. And the reason why I failed, and I think it's funny, it's because it was only because of the human input. I'm gonna play it. Where is, oh, here it is. It was strictly because of the human input. And the calculations were wrong through the physics that we input into Grasshopper. And as you can see, actually, the structure falls upon itself. This is the primary definition that we used, and well, that I created and we used. And what the only thing that was wrong was that the first thing was we were using meters and feet. We're obviously in Hungary, so it was a little bit different. And also the way that I was putting gravity upon this specific object was a little bit different. But once the project was the right definition was put into, gravity ended up being an important numerical factor in our computational logic because it's a real world entity that obviously needs to be taken into consideration. The numerical value that gravity holds is an important element because our structure depends on how much force gravity imposes in a freestanding bending technique. As we move forward, gravity became part of our artistic equation due to the nature of the wood. The allowable stresses for the wood were the foundation of our computational formwork. The reason why we had to put gravity is because we wanted to know how the wood bends upon itself and how much force we can put into it. I actually put MOEs, which is modulus of elasticity, within the parametric equation to know how much was too much for the wood to bend. And this is kind of the natural characteristic of a real life object. And the failure that I showed you on the video was, I think it was really important to me because it's really important to fail early in the stages, especially when you have exactly a week to present. And I mean, I got there on Saturday, and the music festival was the next Saturday. So it was really important to start a digital foundation of a digital framework to start kind of the process of how this is going to look and how it's going to be fabricated. These allowable stresses became boundaries of our design. Allowable stresses were features that were created that created a tangible characteristic of our process. The computational definition finally allowed for the outline of connections between wood components. The numerical values of the connections were extremely important. Our progress and attention to detail was evident as we moved forward because we started to finish things on time and in an accurate manner. This idea of balance emerged from the installation of the concept of rigidity, technology, and artistic perspective. The balance of rigidity versus artistic domination became a very important process to further study within our group. In my perspective, our computational design logic became the symbol of a well-developed set of drafting documents. This elaborate documentation was a pivotal quality in our fabrication timeline because it allowed the further developing of tools fitting for our needs within the design. Furthermore, the documentation of this project enabled each individual to draw interesting personal conclusions and develop an architectural language to further projects. This development was evident in the way we created our tools, timeline, and adaptation to climate. This was the initial fabrication. because of the computational foundation that we created, we knew how tall the installation was going to be, and that also gave us time to select what type of wood we were going to use. That was really important because we had to figure out what is the best quality of wood for our bending techniques. On the left side, on your left side, those two piles right up front showed you the ones that we didn't want to use because of knots, because of thicknesses, et cetera, and on the right is the ones that we chose to use because there wasn't enough any knots for where the bending was going to happen, and also the thicknesses were really similar to the ones that we inputted into the definition. The definition also allowed everybody to know where the specific fasteners were. I pulled a simple list out to know where the intersection of each line was coming, and it just gave me each individual measurement. This was perfect because I created a quick jig, which was on the left-hand side, and you can't really see it. But I created a quick jig where you had the holes, and it was simple for the user to come in with a drilling tool and drill the holes, and every single piece was exactly the same. And again, this high-tech and low-tech approach that I really enjoy, that there's no other technologies other than a computer, which I just thought that it became like the CM of a project. This one, oh, this is. So the wood bending, it became my interpretation of construction and mapping. It was interesting because everything that we took into consideration from the digital computational design point of view became realistic when we started the construction. We knew again how tall this tower was supposed to be and how the wood started to bend in each specific point. The computational logic also helped me out to understand how the structure was going to be held together, because this tower came off later on into the tower actually came out of the construction. And then there was also breaking points where we wanted to avoid, and what we figured out through Grasshopper we were able to get to. This architectural experiment had a variety of controls and values, but it created a methodology of construction and approach. Practical deformation is a detailed process in which a designer, tool, and implementation are synchronized within a world based on adaptation. Each tool we created gave a valuable characteristic to our process, and it granted even more time to adjust for many of the construction developments. One of the big problems that we had throughout the process was environmental constraints, and you can see that this day was actually raining. This is something that it's interesting because you can't put it into Grasshopper until you actually develop a digital foundation. I think in the future I would love to be able to put a plugin like Ladybug or Honeybee to see how long the structure is able to stay up without without it coming down or anything. This is the environmental constraints that we really had. And to end, that was the installation. It had 22 members going each way. I really enjoyed this picture because this was the night that we finished. It was powerful because we stayed a little bit longer just to finish up and enjoy the rest of our days there. We finished earlier than everybody because of the computational logic that we started, and I think it was kind of like this powerful device that we had right under our noses. I wanted to move forward real quick towards the details that I didn't take into consideration when it came to the digital foundation or framework. At the top, those are the connections between each piece of wood. Each piece of wood bends upon itself and connects to a different piece that goes a different direction. So I guess the reason why this was hard to understand is for myself was when they come together, are they going to sustain itself, or how are they going to work when they come together? So this was kind of the fabrication standpoint. The whole user standpoint is the human standpoint, where you can actually dictate how the fabrication is going to further go. And at the bottom is a plate that had to be put towards the end, because when you walked into the structure and start hanging out inside, if you stepped in a wood member, the actual structure started moving, and that wasn't something that we really wanted to have, because of the rain that happened a couple days before, and because of the amount of people that were walking through for the Sziget Music Festival. A few features were the fasteners, and obviously all this fingerprints that the wood had. I really liked the fasteners that were within the structure, because they give like some type of rhythm within the structure and give a different approach to what wood is. When I talk about knots, this is what I was talking about. And these were really bad to our bending techniques and our digital foundation, because they could actually start a breaking point right here. And again, these fingerprints that the wood had was just really a really cool aesthetic approach that the design had. This was the night of the Sziget Music Festival, and I'm not going to show any pictures of the Sziget Music Festival, so I don't think they're appropriate for this computational event. I really think that architecture is always evolving and moving forward. I mean, the investigation analysis thought to fabricate this installation was an amazing opportunity and experience, because it allowed me to develop an interesting approach to construction and design. I've created deeper value for the tools that we have at our disposal as architects, and believe that further working through collaborations is the next step to architectural evolution. My experience within this collaboration showcased the amount in-depth analysis an individual can create when paired with well-minded characters. Computational design and architecture are two very interesting areas which collaboration is essential when it comes to the development of practice and growth. Projects like this one allowed for a level of ingenuity and thought. This movement of ingenuity can be seen in many areas around the world where practice of architecture has become a parallel component to the generation of ideas. Computational design and how we mimic the natural elements is the obvious theme that has been the main focus for this interval of time within architecture. As designers, we have fallen in love with the vast use of wood because of its aesthetic properties and practicality. This concept focuses on the appreciation that wood has already established in its own lifetime. A degree of uncertainty is present because of the materiality precedents that each piece of wood expresses. The software that we utilize is simply a support to design because of the higher level interaction within systems and patterns that we're dealing with. This aid is only a stepping stone, not a restraint to the progress and discussion of new age architecture that has been extracted from natural characteristics. Thank you.